2.7. 2.7. Verify inverse functions. I was trying to say find and verify at the same time. Sorry. Number 2, find the inverse of a function. 3, use the horizontal line test to determine if a function has an inverse. Number 4, use the graph of a one-to-one function to graph its inverse function. And number 5, find the inverse of a function and graph both functions on the same axes. Okay? So, first of all, we need to talk about verifying inverse functions. Okay? Before we can verify an inverse function, I need you to know what an inverse function is. Okay? Inverse of a function. Does anybody remember off the top of their head from Algebra 2 how to find the inverse of a function? What you got? Switch x and y. Absolutely. Okay. So here's the official words that you need to know. Okay. Let f and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equal x for every x in the domain of f. This is how we're going to verify inverse functions. We're going to find inverse functions in a second, just like what you said, switching x and y, right? But to verify inverse functions, we're actually going to use Fogg and Goff, like we talked about in the last section, right? Now, what has to be true about when we do Fogg and Goff? What does Fogg have to equal? X. What does Goff have to equal? X. They both have to equal x. And it's not even that they're both equaling the same thing, it's that they are both equaling x. Well, guys, if you remember that to find an inverse function, you let x equal y and y equal x. Does this make sense then? Because another thing that you can say f of x equals is what? Y. Y equals x, y equals x. Does that make sense? Because we're letting x equal y and we're letting y equal x. So does it make sense that when we do this, we get something that says y equals x and y equals x? Okay, so also, just to make sure you understand notation, what does that mean? That's a function. And what does this mean? That's an inverse, okay? Because sometimes they won't say, find the inverse of the function or verify inverse. Sometimes they'll say, find f negative 1 of x. Verify f negative 1 of x. You see what I'm saying? So I just need to make sure you understand the notation to start with, okay? So, here's what's given. F of x equals 3x plus 2, and g of x equals x minus 2 over 3. This is what's given, okay? Well, if this is what's given, what am I trying to do? If I'm trying to verify, I'm using Fogg and Goff, right? So let's do Fogg first. F of g of x. So I start with f. Anytime I get to an x, I write g of x, right? X minus 2 over 3, and then plus 2, right? So what happens first? What happens with my 3's? Yeah, that simplifies to 1, right? So I just have x minus 2 plus 2. And what happens here? That's 0. So f of g of x equals x. Is it good enough to just say Fogg is x, so they are inverses? To verify, I have to do both, don't I? Okay. I did Fogg and I got x. Now I have to do Goff. G of f of x. Okay. So I start writing g, and anytime I get to an x, I write f of x. So 3x plus 2 minus 2 over 3. Well, what happens here? That's 0. So that simplifies to 3x over 3, and what happens here? That simplifies to 1, so I just get x. Now I have verified that these two functions are inverses. Got it? Any questions about verifying inverses? Okay, now finding inverses. Now, I'm feeling quite positive because you guys already remembered how to find an inverse. So let's actually do it to make sure. Okay, just to remind ourselves, if we need to look back at our notes, we're going to write to find the inverse of a function. What do? Switch x and y and solve for y. Okay? So if I start out here, f of x equals 7x minus 5, and all I'm told is to find the inverse, I just switch x and y and solve for y, right? Well, this is the same as y equals 7x minus 5, right? So when I switch x and y, I get x equals 7y minus 5. So when I now finally go to solve for y, I'm going to add 5 to both sides. X plus 5 equals 7y. And then I divide both sides by 7, correct? So y equals x plus 5 over 7. So in our correct notation then, we're going to go over here and say to ourselves, self, inverse is actually f negative 1 of x, right? Now here's what I don't know. I don't say that very often when it comes to algebra stuff, right? Okay? Not that I know all algebra, but I know a lot of it, right? But this actually doesn't actually have to do with the algebra. It has to do with the computer, okay? I don't know if what the computer wants is that, or if the computer wants is that. You see the difference? But you see that they're the same, okay? But you could get from one to the other if you needed to, right? Okay? Any questions about that? Let's do another one. F of x equals x to the third plus 1. And the directions are find the inverse. So what do I do first? Now, I tell you what, some people, you know what they can do? They can switch x and y like right now, even though there's not a y written. Oh yeah, because we know f of x is y, right? So they can go straight to x equals y to the third plus 1. If you're one of those people, please do it. Yeah, for sure, please do it, okay? You know I did this to make sure that we understood notation. But if that's a step you can skip, please skip it, okay? So now to solve for y, what do we do first? Subtract 1 from both sides. X minus 1 equals y to the third. How do we undo a y to the third? Cube root on both sides here and here. So y is going to equal the cube root of x minus 1. So in our correct notation, f negative 1 of x, our inverse function, equals the cube root of x minus 1. Okay? Any questions about that? You got it okay? Okay, we need to do one more. F of x equals x plus 2 over x minus 3, where x is not equal to 3. Do we know why x cannot be equal to 3? That would make the denominator 0. Excellent. Okay. But if I'm finding an inverse what do I need to do? Switch x and y. So this becomes x equals y plus 2 over y minus 3. You okay with that? Okay. How do I solve that? What do I do? Oh, yeah, I could put this over 1, right? Would that make it a little clearer what to do now? Now I cross multiply, right? It's two fractions set equal to each other. Aren't I allowed to cross multiply? So I get x times y minus 3 equals 1 times y plus 2, right? So on the left-hand side, I'm going to distribute my x. Xy minus 3x equals y plus 2. Now, what do you think is the most common question I get right now? So that's a good question. It's not common, but that's okay. It's a good question. It's a good question. Normally it's, which y am I solving for? Well, guys, how many y's do I really have? I just have one. It's just written in two different places, so I've got to get those together, right? So let's get the y's on the same side of the equation. How are we going to do that? So subtract y from both sides. What do I want to get rid of if I'm trying to get all the y's together? Yeah. So let's add 3x to both sides of the equation. So what I end up with is xy minus y equals 3x plus 2. Exactly. Okay. Now, anybody have any idea how I could get those y's together? Kind of. What if we just factored it out? I saw so many light bulbs just come on. That was so awesome. Okay. If I factor a y out, what happens? What am I left with if I factor a y out? X minus 1. Excellent. And on the right side is still just 3x plus 2. Why did I write 3 then? That's so weird. Look, this should be a 2. No idea. I have no idea. That 3 just jumped right out of my hand. What's left to do to solve for y? Divide by x minus 1, right? So what does y equal? So now what is the inverse of the function? F negative 1 of x is what? We just have to pay attention. 3x plus 2 over, except what? Perfect. Perfect. And why do we have to say that? The denominator cannot equal 0. So 1 cannot equal x, because if it does, it makes the denominator equal 0. So smart. So smart. Okay. Last objective. Okay. I have my piece of graph paper here, so if you have yours, go ahead and get it out. If you don't, I guess you could just cry. Okay. Find the inverse of a function and graph both functions on the same one. Well, horizontal line test, do we need to talk about that real quick? You remember vertical line tests, right? What's a vertical line test do? So if this is my graph right here, vertical line test gives me a whole bunch of vertical lines all the way across the graph to see if the graph is a function, right? It is, right? It is. Here's the deal. A horizontal line test gives me a whole bunch of horizontal lines, right? It tells me what? It tells me if the inverse is a function. Is the inverse of this given graph a function? No, it's not. Okay? Does that make sense? The inverse is not a function because it does not pass the horizontal line test. Okay? Use the graph of a Use the graph of a one-to-one function to graph its inverse function. You ready for that one? Okay. Here's what I'm going to tell you. I'm going to tell you negative 11, 1. I'm going to tell you negative 8, negative 2. I'm going to say negative 6, 4. I'm going to say negative 2, 0. I'm going to say 0, 4. That's what I want to tell you first. So let's get those points graphed on this coordinate plane, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 6, negative, whoops, 6, 4, duh. Negative 2, 0, and 0, 4. Now I'm telling you it's okay to connect these. This is our function. These points that I gave you were the change of direction points of this function. Okay? Or you got it? So if I give you a list of ordered pairs, how do we find the inverse? How do you find the inverse of a function? So how do you find the inverse of ordered pairs? So 1, negative 11, negative 2, negative 8, 4, negative 6, negative, whoops, 0, negative 2, and 4, 0. So now graph those. 1, negative 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, If I fold this paper along the line y equals x, look what happens to these two pictures. They're right on top of each other, aren't they? So that's using, where's my objectives? That's using, oh, it's right here. It's using your graph of a one-to-one function to find its inverse. Find the inverse of a function and graph both functions on the same axis. That's pretty much what we did here, except for the fact that what I give you is like this, y equals 7x minus 5. Plot that on the graph. Switch x and y and solve for y. Plot that on the graph. Guess what's going to happen to comparison of that if I fold it along the line y equals x? They will be right on top of each other again. Okay? We can talk more about that tomorrow if you need to. Otherwise, have a great day. It's okay.